Thanks all for coming. I'm going to be talking about OpenStack and a project on OpenStack called Trove, which does database as a service. How many of you here are even familiar with OpenStack or Trove? We can guess. Okay. I'm sure all of you are familiar with the first two, so we won't bother about that. We'll talk about OpenStack and Trove, something about the architecture of Trove, how it works, what it does, and then drill in a little bit more detail about Cassandra itself, and leave some time for questions. So the OpenStack mission, OpenStack is a cloud operating system. It's open source. You can download it, get it, use it, and it basically gives you the ability to manage your entire data center using a set of open source tools. And Trove is a project in OpenStack. I'm one of the contributors to the project. And for those of you who are familiar with the general way in which OpenStack projects work, I'm on the core review team for the project. Trove's mission is to make it easy for you to use both relational and non-relational databases in the OpenStack cloud. As a point of reference, for those of you who are familiar with Amazon, RDS is the relational database service in Amazon, but there's DynamoDB, which is a NoSQL database, and then there's Redshift. Imagine something which has all three of them in one place. That's Trove. Trove can orchestrate relational and non-relational databases, and we'll talk about some of those as well. Feel free, by the way, to stop any point along the way and ask questions. I know this is towards the end of the conference, so everybody's probably itching to go as well. So stop me anytime you want, and we'll talk about it. So, boy, that's a real eye chart. I'll have to talk to some of these in that case. So this is a typical block diagram of any OpenStack deployment. OpenStack has several services. At the very bottom here is a service called Keystone. Keystone is the identity and access management service in OpenStack. On here is Swift. Swift is an object store. Glance is an image store. Image store is something similar to what AMIs are in Amazon's context. Sitting in the middle here is Nova, which is a compute engine, very similar to EC2 in Amazon context. And the last two are Neutron and Cinder. Cinder is the block store. Neutron is the networking component. And then you have a user interface. And then the user sitting up top interacts with all of these. For those of you who are trying to magnify this picture, I apologize. There's a URL sitting here in the right-hand corner. All of these slides are available online on our website, tesora.com/slides/Cassandra Summit, if you want. This particular image is also available in the OpenStack documentation. So this is just a schematic of what a typical OpenStack deployment would look like. A brief history of where Trove came around. Trove is, again, database as a service. So we assume that in order to use Trove, you have a functioning OpenStack environment, meaning you have Keystone for identity management, identity and access management. You have Nova functioning. You have storage with Cinder and Swift. You have Neutron, and you may have a user access console. But as you progress beyond just running VMs with your application in it, you find there's a value to have a managed database. And the folks at HP and Rackspace sure found that. We have, purely by coincidence, we have one person in the room here who is one of the guilty parties in this group here who originally started out Trove. Eddie, I can see you're there. And that was way back in 2012-ish. About a year later, in the Havana release, and by the way, OpenStack releases go on a 6-month cadence, alphabetical. So the Liberty release either just came out or is just going to come out. But in Havana, Trove got into incubation, meaning you could try it out. It was already in use by people like HP and Rackspace, but you and I could get a copy of it. In the Icehouse release, it finally came out. My company became part of the OpenStack community at that point or a little bit earlier, and we started working on Trove there. And over the next 2 years, over the past 2 years, that is, Trove has grown to support several databases. In the initial release, Trove supported MySQL, Mongo, Cassandra from community, and maybe a couple of more. But over the next couple of releases, we've added support for a whole bunch of new features. And the basic reason for this is to make it easier for you to run databases in your infrastructure. And we'll talk about the use cases in a short while after we kind of understand some of the piece parts here. Okay so far, or? Okay. So I'm going to spend a bunch of time on this slide, which talks a little bit about the architecture of Trove. You see some of the same names you saw before: Keystone, Identity and Access Management, Neutron for networking, and the 4 major services in OpenStack which really do the bulk of the work. You have compute from Nova, storage from Cinder, object storage from Swift, and images from Glance. The database as a service part, Trove, or the platform which we distribute, is here on the left. So like every other OpenStack service, Trove exposes an API. This is a standard RESTful API. And you can make requests to this API to do things like provision me a Cassandra instance, provision me a Cassandra cluster, provision me a MySQL instance. All of those things come in here. There's a couple of other components in Trove which we'll talk about, but let's talk about a typical request which you may make. As a user, you may say, and again, to use an Amazon analogy, if you wanted a MySQL database or a Cassandra database, you could go to EC2, spin up an EC2 instance, install your software, and you got a perfectly good running database instance. Or you could go to RDS and make a request and say, give me an RDS MySQL instance. Making a request to Trove is like making a request to RDS. So you make a request to Trove and say, give me an RDS instance, or in this case, give me a MySQL instance or a Cassandra instance. It is now Trove's responsibility to orchestrate the rest of OpenStack to give you a queryable endpoint. So I could make a request to Trove and say, give me a Cassandra instance, and the immediate response you're going to get is going to be, your connection string is this, and this is your instance identifier. You can then go and pull that instance identifier to figure out when that instance comes online. It takes about a minute. You'll get a running instance. At that point, that connection string is a standard Cassandra connection string or a MySQL connection string. Trove is not in the middle of that data path. You interact with that database exactly as you will if you provisioned it on a bare machine. And the architecture of Trove is like the architecture of every other OpenStack service. There's the API, which does the RESTful API. It's just a Whiskey server. All the heavy lifting is done by a task manager service. Trove has a Trove task manager. And when you provision a database instance or instances, under the covers, you're provisioning a Nova instance, which is a virtual machine typically. And on that virtual machine, you have the database that you chose. If you chose MySQL, you get a MySQL database there. If you chose Cassandra, you get a Cassandra database, and so on and so forth. Storage for that is attached from Cinder. So you have some some set of storage which is managed for you by Cinder. Trove is going to make a request to Cinder and say the user requested a 50 gigabyte volume or a terabyte volume. That volume is now attached to your instance, and that's where your data gets stored. Okay? I'm going to pause here and see if anybody has questions at this stage. Go ahead.
How do you select what type of database you want?
Oh, okay. Very simple. So for those of you who couldn't hear the question, how do you select what kind of database you want? The Trove API request for create is the same API call no matter what database you want, but in the request you specify the data store. So the data store could be, at this point, MySQL or Percona or PXC, which is Percona XRDB cluster, or Postgres or Mongo or Cassandra or Couch or Redis or Vertica or DB2 Express or Oracle. You specify the name of the data store. For each data store, you could have multiple versions, so you also specify the version. So you could have Oracle 11g and Oracle 12c. So you would specify, I want an Oracle 11g instance. So you provide those two parameters. You're also required to provide a flavor, which is a Nova flavor, and you're required to provide a size for most data stores, except for Redis, which doesn't require a backing volume. Those are the 4 parameters you provide. On a per data store basis, you may provide additional information. So for example, if you're provisioning a Postgres instance, you could give other Postgres-specific information in the create command. All that shows up in the API call. That is then used by Trove in assembling the instance you want. Make sense? OK. There aren't too many of those right now. What database were you thinking about? Sorry, the question was how easy is it to add a database which is not supported, but which database did you have in mind? Aerospike, OK. So adding a new database is not, it's not very hard. It's not trivial. There's a set of things which you need to do. So in Trove, you can define a data store to be in one of 3 levels of maturity: experimental, or in test, or in production. In order to get a data store which is experimental, you need to support at least the create request, a shutdown request, of course, and potentially a resize request. So effectively, you need to implement a guest agent, which is a little Python library, which is going to run on each instance with your data store. And it needs to understand 3 or maybe 4 API calls. Not very hard. There's some work involved. But that's just a basic support for a database. Now, we'll talk in a bit, and I'll come back to your question about what it takes to add a data store. Trove can do a lot of things for a database. I don't know about the architecture of Aerospike and what all it can do, but let's talk about, say, a database like Cassandra. Provisioning a single instance of Cassandra is not hard. Provisioning a cluster of Cassandra is harder. Doing a backup of a single instance of Cassandra is not hard. Doing a backup of a cluster is harder. Trove supports backups. So you need to implement code in your guest agent which understands how to do some of these more esoteric operations. Resizing an instance. So you launch this instance with whatever database you want, and you find that you chose the wrong flavor. You want a bigger instance. There needs to be code in your guest agent which understands what to do in order to resize the instance. So those are all incremental features which you can add to your guest agent. Then you can get it to the level where you say it's test ready. Maturity is test ready. In order to get it to the point where you say it's production ready, you also need to provide a continuous integration environment where it will be continuously tested. There are some other requirements depending on the licensing of the database. If your database requires, for example, a licensed binary to be downloaded and a complicated click-through mechanism, then you need to provide a mechanism where the test infrastructure can, in an automated way, do those things. So there's a set of things which we do, and I'll try not to make this a commercial from my company, but if you want to add Aerospike, speak to me after the call, and we'll tell you how to do it. There's some money involved there. So. Other questions? OK, so the crux of this entire architecture is that on a per database basis or a per data store basis, MySQL, Cassandra, what have you, there is some custom code which is implemented in a guest agent. And the guest agent understands how to perform that specific operation for that database. Doing a backup on Oracle is different from doing a backup on MySQL. Trove supports an API called backup. The code to do the specific thing for each of these databases is buried in the guest agent. OK? That's about all I'm going to talk about on architecture, unless anyone has other questions specifically. OK. So I guess the question is, what are all the things that Trove can do for you? And this is maybe a partial list. We've talked about many of these things. Provisioning a single instance, not very hard. Give me an instance of Cassandra. You're doing some development. You want to spin up a single instance of Cassandra. You want to run some queries against it. Great, you can do that. Some databases support replication, either for performance reasons or high availability reasons. Trove supports that. Give me a cluster. Okay? All of you have probably heard a lot about Cassandra's clustering capabilities. Many databases support clustering. Trove supports clustering. I will caveat and say, not all databases support all of these capabilities. At this point, for example, clusters are supported in only a couple of databases: MySQL with Percona, Vertica for Vertica clusters, and Mongo for Mongo clusters. Cassandra clusters are coming. We'll talk about that in a second. The ability to do backup and restore. For small data sets, this is very easy. Stream the data out somewhere, and if you want to restore it, load the data back. How do you do it when it's a larger data set? Trove has automation for that. Replication and clustering, we talked about that. A very important use case for Trove is configuration management. So if you happen to have hundreds or thousands of database instances, each one of these database instances has a config file of some kind. Now, assume you want to make a configuration change to all 1,000 of these. Doing this manually is very, very time-consuming and very error-prone. So Trove gives you the ability to say, create a configuration group and attach it to a whole suite of instances. And now it's Trove's responsibility, and we'll talk about how it does some of these things. And resizing it. You have a small instance, you want to go to a large instance. You have small storage, you want to go to large storage, so on and so forth. The basic theme you have here is automation. So the idea is that you should not have to do all of this stuff manually. Databases are a pain in the neck, okay? You have very, very little room for error. Setting it up is hard, sometimes a nightmare. Keeping it running is also a full-time job. Of course, you don't want to have a situation where you either lose data or somebody can break in and steal your data. And in an organization, you typically don't have a situation where you have just one database. Many organizations, many applications these days have multiple databases. Some use a SQL database and a graph database and some key value store. And in the old days, you had an IT organization which had all the expertise on every database known to man. Now that's no longer the case. Very often, this information is fragmented through the organization. If this is the problem you face in an organization, one of the good solutions is to automate everything you possibly can do. And that's basically what Trove does for you. It addresses the issue of setup by completely automating that. It addresses the issue of configuration by completely automating the ability to manage configuration, not for a single instance, but for a whole group of instances. And for all complicated configurations, clusters, replicas, and all of that, Trove manages that for you. And Trove supports a whole bunch of different databases. We'll talk about it in a bit. Questions so far? Okay, go ahead. So when one first works with Trove, is there any training or, I hate to do this, but we wrote a book on Trove, so you can happily buy a copy of the book. I have a couple here if people are interested in the book on Trove. We offer training as well. But Trove by itself is not if you're an end user of Trove, it is relatively easy for you to get Trove up and running. If you have OpenStack up and running, you're probably running OpenStack on one of maybe 4 different operating systems or distributions. For each of these, there's distributions of Trove, which with one command, you can probably get it installed. Maybe 1 or 2 commands later, you can get a guest image for just about any database. You start with the database you're familiar with. In terms of complexity, I would say an average engineer kind of person, a couple of days, and you'll have something which you can launch your first instance. And the nice thing about it is you can run all of OpenStack on a modestly sized laptop. So on just about any operating system, stick VMware on it, run an Ubuntu VM or a Red Hat Fedora VM. You can run OpenStack on that. So it's not, you don't need to go have a huge infrastructure either. Does that answer the question? Yeah. Okay. All right. So again, to kind of sum up what Trove does for you is It gives you a common API for a whole bunch of different database operations across a lot of databases. And it allows you to do standard constructs, replication, clustering, HA, things like that. Many management operations, backups, configuration management, and things like that. And very important thing at the end is, even in an organization where you do not have a lot of expertise on every last detail about a database you're using, the automation built into Trove embodies the best practices for that database. So the guys who contributed the code for MySQL originally, one of them is sitting right here in the room, operated maybe thousands of servers running MySQL, and the best intelligence they had about how to manage that was built into Trove. The guys who contributed the code for Mongo clustering operated thousands of nodes of Mongo in a production environment. Therefore, they put the intelligence on how to do that into the code for clustering. So you're getting all of that as part of Trove. All right? So let's talk about a couple of very simple operations which Trove does for you. A single instance, provisioning a single instance, the most common thing which somebody starts with. What is your request? What data store? What version? What size do you want? And what database, of course, it's going to tell you. Between these two and the flavor of the instance, that's all you need to know. What Trove's going to do is validate your request, provision the storage, provision the networking, do all of those things, tie it together, apply the configuration, and hand you back a connection string. So effectively, this entire operation is automated for you. Okay? Relatively straightforward. This is a request, RESTful API, web UI, CLI, whatever you want. Endpoint is a connection string. Okay, let's try another one. I took a backup of a database, or no, let's say I want to take a backup of a database. Indicate which instance and say you want a backup. Trove's going to verify that you can take the backup. Do you have the privilege to do that? It will execute database-specific code to do the backup. Now, depending on your database, so MySQL, you can do a backup in one of 3 different ways. You can take a backup as a MySQL dump. You can do a backup as a Percona XtraDB backup, or as an incremental backup. All 3 are supported. So you could specify, I want an incremental backup, in which case you specify what the parent was. Trove will take care of all the MySQL-specific code to do that, and it'll push the backup onto Swift, all done. All you get at the end of it is a completion status, yes, no, otherwise. Okay? So all the hard work involved here, done for you. I'll point out to you that it might be easier if you follow that little URL at the right-hand side here. All the slides are available there, so might save you the photograph. Now that you created a backup, what can you do with the backup? Okay, I took a backup. Give me an instance based on that backup. Right? So load from that snapshot. Again, same 3 things, and identify the backup. Trove will create the storage, provision the instance, load the backup for you, and hand you the same connection string. All done for you. Similar, I have a single instance of a database, provision a replica for me. I'm finding that my master is getting beat up. Give me a read replica. All you need to tell me is the same 3 things, and you tell me what the master is. Trove is going to launch the replica for you and give you the connection string. Now you have 2 databases. Load balancer is not provided by Trove. If you want to have a proxy, that's up to you. Another simple use case, provision a cluster. And this is something which is going to be supported for Cassandra very soon. Give me your cluster configuration. In the case of Mongo, for example, when you say, give me a Mongo cluster, you specify how many data nodes you want. That's it. You will get that many data nodes. You will get some number of query routers, some number of config servers, all provisioned for you and up and ready for you with a completion status, and you'll get a connection string. Behind the scenes, there's a complete cluster. At that point, you can start managing the cluster as a cluster rather than as individual instances. Okay? And once you have the databases up and running, I now want to apply some change to it. So I'm running the database, and I want to change the amount of memory I allocate to something. I want to change some config parameter. And I want to do this not for one database, but for 100. Tell me the configuration group, create a configuration group, and the instance or instances. At this point, it's Trove's responsibility to verify your request is correct, and then apply those changes. And there are some changes which may require a reboot. So if they require a reboot, it will flag the instance as reboot required. It's not going to reboot the instance for you. If the change can be done without a reboot, it's done live. All you get is a completion status. Question?
No, I was just saying there are dynamic changes
Yes,
and there are dynamic
and yeah, so this is typically the case with a database. If you're required to reboot, there's knowledge within Trove on which changes require reboot, so it will flag it appropriately. Okay? So currently, Trove has no ability to schedule a job for a particular time. However, all of the commands, all of these requests can be done either as an API call or a UI, but also from a CLI. Cron works just fine. And that's typically the way in which people who've deployed Trove do some of these. But again, there's a RESTful API available. If you want to build some automation around Trove to do some of these things for your own deployment, you could build it through that. Other questions? Okay. So I have a cluster of instances, and this is something which is not currently supported for Cassandra, but let's talk about, say, Mongo or Percona. I have a cluster. It has some number of instances. I can grow the cluster. And growing the cluster requires some specific set of operations on Mongo, which are different from the operations on Percona or Vertica. And I'm sure they're going to be different from the operations you'd have to do on Cassandra. So Trove will take care of that for you. It'll provision the new instances, and it'll add it to the cluster in some mechanism which is appropriate for the database in question. All you need to do is say, this is the new cluster configuration. The actual magic under the covers, taken care of for you. Okay? So we have a couple more of these. Resize an instance. I was running an instance. I provisioned it on a small instance. Small instance is not big enough. Make it a large instance. Give me the new instance size and tell me which instance you want. It's now up to Trove to figure out how to do that. Now, I call this resize an instance, but this is a very, very powerful construct which a lot of people use with Trove, where different flavors, small, medium, and large, are targeted at different hypervisors. And different hypervisors can provision databases from different physical hardware. So I can launch an instance in a QA environment or a test environment running on some hardware, development hardware. And then by the operation of resize, give it a, quote, production flavor, which effectively migrates the instance to production-grade hardware, SSDs, more memory, all that fun stuff. All managed for you by Trove. So you provision your database once and just resize it onto new hardware. And that's something which a lot of people use when they migrate an instance from dev through to production. OK. So I've talked about a lot of things which Trove can do, but it can do this not just for one database. We've seen earlier today, I saw a presentation from somebody who talked about database as a service for Cassandra. I agree with the premise, but I think a lot of companies have more than a single database in their shop. And the value of Trove is that you have a common API for all of these databases. The API you call to create or resize or whatever, a MySQL instance and a Cassandra instance, exactly the same API. There's additional information you could provide if you're launching a MongoDB cluster, like how many data nodes you want, which you wouldn't provide if you're launching a single instance of MySQL. But it's still the same create call. Makes it very useful from a perspective of building this into some workflow which you have within your own organization. I list several databases here. I list a little asterisk at the end here. Oracle is not supported by OpenStack Trove, the open source version. My company provides a distribution of Trove which does support additional capabilities and databases. One of them is Oracle. And also, in Trove, not all databases, this is important to understand, not all databases support all capabilities. You may be able to do a lot more with MySQL, which has production-grade guest agents, than you may be able to do at this point with, say, DB2 Express, which has an experimental guest agent. At this point, I don't believe, for example, that you can do a backup with DB2 Express. It's available as a development tool, but it will be improved over time. But you can do a lot more things with some of the other databases. Okay? So we talked a lot about a bunch of databases. Let's talk specifically about Cassandra. Trove has supported Cassandra from the very beginning. From the very first release of Trove, there was support for Cassandra. And you could and you can today provision a single instance of Cassandra, use it for development purposes, and the Cassandra which it provisions is Cassandra from the community, Apache Cassandra. Support for clustered configurations is something which is coming soon. That'll probably be in January. And support for DataStax Enterprise is something which we're adding, which will come out a little bit later. That will be in our enterprise product. It'll probably not be in the community version of Trove for a while, licensing reasons. And I've talked a little bit about my company. I've mentioned it. So who are we? We're the company who, we're now the largest contributor to Trove. We were not the people who originated this project. The project was originated by people at HP and Rackspace, and we cannot claim credit for that. We came onto the project well after they had laid a solid foundation. But at this point, we're the largest contributor to the project. We have the largest team of people working on it, on the open source version of the project, at least. We provide a enterprise-ready version of Trove, which you can use. You can download it on our website, www.tesora.com. It is based on Trove. It has several extensions to Trove. And some of the things which make our product different are that we provide guest images for many of these databases. Trove itself does not provide guest images. If you download Trove from the community, you get elements. You build your own images if you want. Of course, we provide support and services. We support Oracle today, which is not supported in the community Trove. And we release our product every 3 months. OpenStack releases every 6, so you have some early access to features. I said we wrote a book. I literally wasn't kidding. We have a book if you want to read it. And we're hiring. So that's all I had to say. Let me stop and ask if anyone has questions. Not quite yet. Oh, cool. Thank you. No questions.
Out of the microphone for any questions anybody may have.
By the way, I have 5 copies of a book, and I swear I'm not going to take them back with me to Boston.
Are you going to be contributing back the Cassandra cluster code to the open source
Sorry,
project?
say that again?
Are you going to be contributing the Cassandra cluster code back to the open source project, or is that going to stay internal to your branch?
So the question, yeah, well, everybody heard the question. Let me think about that for a second. I believe the Cassandra cluster code is going back to the community, so yes. The code to support community Cassandra will be in the community version of OpenStack, a community version of OpenStack Trove. The code which supports DataStax Enterprise will be in our enterprise product. There are some deltas. There's additional configuration which we need to do for DSE. Those things will be in our enterprise product. Other questions? Yes, sir.
Just curious, for backups, do you support backups in the Cassandra plugin? And if so, how do you handle that as far as do you snapshot the entire cluster, or what's your process for that?
Excellent question. Do we support backup, and how do we do it for clusters? no matter what the database, Trove does not implement its own code for backup. We do whatever the database vendor says you should do for backup. I believe the recommended way of doing a backup for a Cassandra instance, one, is node tool snapshot. I'm not Cassandra certified. I believe a bunch of you here are. So correct me if I'm talking BS about Cassandra. The way in which you do a restore is similarly you copy some of the files over and hard link X to Y and whatever. Whatever those best practices are, it's exactly what Trove is going to do. When it comes to snapshotting a cluster, I attended a presentation yesterday to listen to what Ops Center does. We have two avenues ahead of us. One option is to leverage Ops Center and do the Ops Center way of doing a snapshot of a cluster. And the other is to reinvent that and do those same commands one node at a time. I don't know what the final implementation is going to be. It's going to be one of those two. It's still a work in progress. Sorry, the question is, do you baseline a system when you provision them? By baseline, do you mean run it to make sure the performance is reasonable or something like that? So at this point, Trove doesn't do anything like baselining. We could talk later, and there may be ways in which you could do that. Trove itself does not, but if you're interested in that, we could definitely chat about how you could achieve the same thing. Correct. Mm-hmm. Correct. So again, the question is, if you provision a new instance, you should automatically collect a baseline, and currently we don't. One part of OpenStack, which I entirely glossed over, is a project called Ceilometer, which is an eventing and event tracking mechanism. Every component in OpenStack reports events to Ceilometer. Trove reports several events. It's a matter of extending Trove to potentially report baseline events, performance events to it. We do get some sense of it because we know that launching an instance should take about two minutes. At least it does that on my laptop. On a production environment, I can do it in slightly less. We do time how long it takes. If a certain instance takes 6 minutes to launch, that's a good indication that there's something screwed up with that. That could be information we could use, but currently it is not used.
And for the last question, we have one over here.
Okay.
My question is for when you're provisioning a database, instead of using Cinder, is there any options of doing like more of an instance store?
So the question is, can you use instance store rather than using Cinder? So Cassandra users have asked about this a lot because Cassandra's or DataStax's recommendation is you use local storage. You can create a flavor which goes to a hypervisor where storage is guaranteed to be local. So Trove doesn't get involved in that, where's the storage at this point? We give hints to the underlying projects on where they should go provision their piece parts. Therefore, you can achieve exactly what you're talking about. That is something which we do so for example, when you graduate an instance from a development instance to a production instance, you could say, on the development instance, I want to run on spinning Rust. In a production, I want to run on locally attached SSD. That's exactly how you would do this, by saying, this flavor only works with this hypervisor. This hypervisor is only supported on this set of instances, or this set of physical hardware. And that physical hardware has local SSDs, as opposed to the other one, which is a development flavor, which connects to a NAS. So it's not a direct solution, but Trove doesn't directly get involved in storage, so we have to use the other underlying projects for that. Thank you.